Meet Hank. He's not just any technician. He's the guy who gets it done. Fast, efficient, accurate, but only because he's got the right tools in his hands. Evergreen telemetry gives HVAC pros like Hank the ultimate advantage. No more guesswork, no more wasted time. Just fast, reliable wireless airflow measurements so you can move on to the next job.
When airflow's tough and time is tight, Evergreen telemetry makes it right. With tools so smart, so easy to use, we'll help you when you've got nothing to lose. Faster, safer, smarter too. Evergreen telemetry's here for you. From homes to labs and enterprise halls, we've got the tools to do it all.
Good afternoon, everyone. I'm Cassie with AABC, and I'd like to welcome you to today's Tab Talk webinar. I also want to thank our sponsor, Evergreen Telemetry, for supporting this session. Just a few items to cover before we get started. Our presenters will hold questions until the end of the presentation, so we encourage you to submit them at any time during the webinar using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform the panelists so that our producer, Will, can assist you. This presentation is being recorded and it will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you're a certified TBE or TBT, your CEUs for attending this webinar will be automatically uploaded to your respective portal after the webinar. Today's webinar is Periodic Tab of Existing Buildings. I'd like to welcome our speaker for today, Troy Byers. Mr. Byers is a professional engineer, certified commissioning authority, and test and balance engineer with decades of experience in the building systems industry. He began his career in 1984 as a nuclear propulsion plant operator in the U.S. Navy, gaining a strong foundation in mechanical systems and operational discipline. Since 1995, he has specialized in testing, adjusting, and balancing, bringing deep technical expertise to both new construction and existing building projects. Currently based in the Charlotte, North Carolina area, Mr. Byers collaborates closely with TAB firms, providing commissioning and retro-commissioning services that ensure optimal building performance and energy efficiency. Without further ado, I'd like to hand it over to Troy to kick us off.
Thank you, Cassie. Good afternoon, everyone. Good morning on the West Coast and beyond. And welcome to our webinar today. At any time, if you want to add comments to what we're talking about, feel free to add to the Q&A. And then if there's any questions, Cassie will be monitoring the Q&A. If you want to sort of raise your hand and get a clarification on something as we go, that's fine. But, you know, we can't overstate the significance of HVAC in buildings, because without HVAC, you know, buildings just can't function. And the environmental impact of HVAC in existing buildings is also significant. So, you know, we have ASHRAE standards that address energy saving designs for new construction, but environmental impact of existing building energy usage is much greater. And so if we consider HVAC to be the lifeblood of a building, the TAB professionals are the instrument that provides the vital signs. So together with ASHRAE standards, AABC, ACG, and EMA efforts, buildings can perform better and be more efficient. So today we're going to open the lid on several topics that could be explored further, and I hope we get into that as we go through today's webinar. But the goal of this webinar is to get us thinking individually as to how to collaborate as an industry to establish ourselves as the leaders in building performance. So with that, we'll go ahead and get started. Excuse me, as we try to advance a slide here. There we go. Our learning objectives. I'll let you guys read through those. Again, we're gonna talk about a lot of different topics here, and I want you guys to feel free to add comments and share your own experiences as we talk about examples and things like that. So why is periodic tab important? So what we're looking at, we've got energy savings, we've got improved comfort, and we've got extended system life. So what do you think of when we bring up this topic with regard to different types of facilities you've been in? Because I immediately start thinking of infection control, the ASHRAE 170 requirements in healthcare settings, critical care environments. Think about smoke control systems, whether we're talking about stairwell pressurization, or maybe you've got a detention center with smoke zones that relies on pressure boundaries. So Will, if you could help us with a polling question, let's just poll the audience with number 1 here. How many attendees are currently performing annual testing of HVAC systems, specifically for ASHRAE 170 compliance in your hospital OR suites? Okay, we'll keep that open for another second and let's see what we've got there. So a good number of you, but there's about a half and half, a little, let's see, 60-40, 60% have not. So what we're talking about there with the ASHRAE 170 compliance is in the ORs. We'll use the specific OR criteria. We have a certain number of air changes that's required in that OR suite, and we have a certain amount of pressurization and positive pressure that's required for that room. There's also temperature humidity requirements, but our primary goal of going through and measuring is to determine that we've got the proper number of air changes and pressurization throughout the OR suite. The decontamination rooms are negative, sterile storage being positive, OR suites positive, and this is required typically annually so that hospitals can stay in compliance with their accreditations. So frequently, tab firms get engaged in that kind of periodic testing. So that's one example. Let's go ahead to polling question number 2. So how many attendees are currently performing annual stairwell pressurization or other smoke control systems testing, which would be required for life safety? All right, let's see what we've got for the results on that one. So again, about a 60-40, 60% no, and 40% yes. So if you haven't been involved in that, just taking the stairwell pressurization as an example, what we're concerned about there is pressurization, a positive pressure in the stairwell to provide us a tenable environment to egress a building, say a high rise, anything 5 floors or greater, to make it down the stairwell safely with no smoke, bringing in fresh air from above and pressurizing the stairwells. But we don't want so much pressure that we can't enter the stairwell by opening a door. So we've got a limit on the amount of force that's required to open those doors. So we'll be measuring the force required to open doors, and we'll be measuring pressurization at each floor to ensure that we're within the proper guidelines. This might be required by code. You might have a code enforcement person with let's say with the fire department, a fire marshal that's coming around and making sure that buildings and building operators are performing this testing to ensure that their equipment is being exercised and that everything works according to the design. Okay. And one more question. We actually have 2 more questions, but polling question number 3. How many attendees are currently performing annual fume hood systems testing for life safety? So a lot of labs, whether it be universities or what have you, that utilize fume hoods, have them annually certified through their own occupational safety programs or code compliance. Let's see what the results are on number 3. about the same split. So we're getting a consistent split here for this type of annual testing. And then one more, number 4, just to try to understand here how many are not AABC certified. So if you're attending this webinar today, but you're not an AABC firm or certified, let's just get a read of the room there. All right, Will, what do we have? 24% yes, 76% no. And that definitely aligns with why we're seeing some of the higher numbers that have not performed this type of annual testing, and working in a existing building in that sort of approach. So, all right, with that, we'll go ahead and move through. Okay, so typical key components that are involved in the testing and balancing of HVAC systems. We see air handling units as the source of conditioned air, and then going out into terminal units for distribution, ductwork, ventilation systems, pumps, fans, cooling towers. These are some of your major pieces of equipment, with boilers and chillers, and then the control systems themselves to maintain our temperature and humidity and sequencing of our systems. So one of the things to think about when we're doing existing tab in existing buildings, I should say, is there's a reason we've been called out to an existing building. Typically, there might be an issue, there might be a known load or capacity change or change in use, that we're going out there to check all of these components that we just talked about and measure and find out what's going on. So we need to have in the front of our mind that we're going to go in this existing building and start analyzing and measuring, but looking for ways that we may have to get involved in basically a recommissioning effort. Okay, so when we approach this air handling system, one of the things we want to do is measure and find out the existing capacity of that air handling unit. And so we want to start by measuring the RPM, the airflow, the fan RPM, the airflow, the total static pressure, determine the brake horsepower measured electrically, and let's get a manufacturer's fan curve for this particular unit and find out where we are on that fan curve. Because A, we need to know a baseline, what we have, and then B, we need to know if we have any adjustment, if we need to try to go up or down based on current conditions. So we want to get a static pressure profile across that unit, meaning measure the pressure in each area of the air handler across any component, such as a fan or a filter or coil or dampers, to see what's going on, where the air handler is utilizing power to overcome resistance within the unit. And so then we want to get the coil capacity, so the heating and cooling coils. If they're water, we're going to get the entering and leaving water temperature and water flow. We're going to get entering and leaving air temperature across each coil to determine the capacity of that coil. And so what we start thinking about and contemplating as we're going through these systems and observing them is, what is the capacity? What's the control strategy? How are we controlling that unit to achieve the desired leaving air conditions? We want to look at current sequences and try to determine if there's some energy saving opportunities as we go through basically a recommissioning effort, as we're looking at any existing system, to see if maybe we could employ a static pressure reset strategy. Looking at the static pressure in the duct if it's a variable air volume system, and the controls can poll each terminal unit looking at the damper positions. And if any damper is not, at least 80, 90% open, then basically we have too much static for the given load conditions. And the static pressure set point can be reset downward incrementally until we see those terminal unit inlet dampers begin to open up more and relax that system. So now we're using less energy. Another strategy would involve temperature reset of the supply air temperature. Supply air temperature reset recognizes that we've met our load in the space, and so we can start letting the temperature of the discharge air increase. And so now we're using, if say it was a chill water system, we're using less chilled water to maintain that low discharge air temp. And we're also using less reheat, whether that's electric or hydronic, but we're using less reheat to maintain space conditions. So obviously you have to be careful with humidity control. If you raise that supply air temperature, you're also allowing, the relative humidity to increase there. So watching out for that. But another strategy is demand control ventilation. Looking at the occupant load and the CO2 in a building, we could decrease the outside air, which reduces the load on the air handling systems in that way. Other examples are there. You could look at a constant volume unit and add a VFD to the unit and allow the unit to ramp up and down based on a load in a given space. And with all systems, with all buildings, we want to pay attention to building pressure, okay, and under varying sequences of the air handling systems. We want to pay attention to building pressure when we arrive at an existing building to see what's going on, because building pressure plays a critical role in how we're conditioning outside air. We don't want to have a lot of infiltration, and we'll talk about that a little bit more later. If you have some other examples of sort of the recommissioning of air handling systems and control strategies you want to throw in, just please feel free to add something to the Q&A there. Okay, and then going on into the distribution with terminal units. So this is a pressure independent fan powered terminal unit that we're looking at. And so we're going to take the medium pressure air from a VAV air handling system through that inlet and measure the airflow with those pickup tubes there that are connected to a flow ring. So an airflow measuring station there that allows this terminal unit to be pressure independent and control airflow based on the set points between a minimum and a maximum airflow. So when we approach this terminal unit in an existing building, we want to pay attention to the filter on that unit and see if we've got a filter there to begin with, which might lead to some other maintenance requirements. But we want to pay attention to the filters on that unit. We want to look at those velocity pickup tubes that are shown there and verify the integrity of those tubes, because that's what's controlling the airflow based on a differential pressure sensor that they're connected to. So we want to make sure that that unit is calibrated. So measuring the airflow at the distribution or measuring the total airflow at the inlet of that box with our tab instruments and comparing that measured airflow with the reported airflow in the building automation system. So maintaining calibration of those units will help us improve our efficiency of the unit and improve the performance and the comfort for the occupants. There's a damper shaft that is sometimes used on these to rotate a damper. And we want to make sure that that shaft is aligned with this actuator so that it fully closes and fully opens. Otherwise, we may have some added resistance. For instance, if a damper is not opening fully, causing us to have higher system static to overcome that resistance of a partially open damper. And so then we're also looking at capacities, both airflow, meaning go ahead and take that VAV box to its maximum CFM setting, measure, minimum CFM setting, measure, make sure it's controlling between minimum and maximum. And also for any reheat, measuring the capacities there. Again, it could be, hot water reheat, measuring the entering and leaving water temps, water flow rates, and then entering and leaving air temperatures. On the electric side, we would also be looking at the kW, measuring the kW of the heater, making sure we're matched up with the rated kW, and then any staging that's required by the electric heat to determine if that's sequencing properly. Okay. And then other areas within HVAC systems that will can impact performance is take an example here of duct leakage. Sometimes we see abandoned duct runouts that have not been properly capped or blanked off, or something has come loose that was previously applied to block an abandoned runout. We also have access doors throughout duct work. Let's say to access, for instance, a fire damper. Well, these fire dampers are also periodically inspected and tested. And so, it might be that a door didn't get closed properly, or maybe a fire damper doesn't get reset. So one of the very important elements, if we didn't touch on it in the air handler slide, is a system static pressure profile. And so we talked about a static pressure profile of the air handling unit itself, but I don't think we touched on the system static pressure profile, meaning going out into the duct system, and you could measure duct static at, a quarter, halfway, and 3/4 down a given VAV system, for instance. Or if you have vertical duct going down a shaft, you could measure at different points in the distribution of that duct. But what that's going to identify is any, high pressure losses, and a shut fire damper would definitely give you a high pressure drop from one side of that damper to the other. So it's going to help you troubleshoot and understand maybe, any issue that has occurred in this existing building due to whatever reason, that might take place. Again, damper alignment comes into play with like smoke dampers to make sure that the damper is fully shutting and fully opening and aligned with its actuator. Return air plenums, where we have plenum air return, going back to maybe an air handler that's located centrally on an office building floor, for instance. All of the return air goes above the ceiling through plenum and travels back to that central location. So we want to observe any blockage, again, like fire dampers and rated walls that might be closed and preventing that return air path back to the unit. Also, return air path or transfer air path in conditioned spaces to make sure we have a transfer grill, for example, in each office space or in each enclosed space to get that return air back to the unit efficiently and with the least amount of pressure drop. Central energy plant optimization could be a whole project in and of itself, where optimization systems are continuously monitoring and analyzing real-time data from various sources, such as your building loads and your weather conditions, utility rates even, to make these real-time adjustments to equipment operation. And so the system can adjust the sequencing and the staging and load sharing to achieve the most efficient operation and for the lowest cost for given conditions. Pretty advanced stuff with some pretty intense algorithms that make that work. But without it, you're not going to get that efficiency. When we use the acronym PVT for the BAS is the Building Automation System, and PVT is a performance verification test that we see in federal work. It's in the specifications that the controls contractor go through a performance verification test, basically a point-to-point to ensure that each controller or controlled device is receiving the proper signal and responding accordingly. For instance, a damper that controls outside airflow, when it's commanded to 0%, that it actually closes, 100% fully opens. If there's a flow measuring station associated with that damper, that the damper responds to flow set point changes, and so proving that the flow station works properly, and that the damper responds properly to its set point changes, but applying that to every single controller on the project. So we think about this in existing buildings. There's always an opportunity to implement this same approach to go through a system, all of the controls, to ensure that we're getting the right responses, and that again, dampers have the proper alignment, and they're not binding, and everything's working according to the design. So part of an ongoing and periodic tab of existing buildings, if you have a program of periodic maintenance, one of our points of failure is belts. I mean, these belts should be inspected annually, but in many cases, we out there in the field, we see many cases where we know that these belts have not been changed or tested, checked in years. So that's a point of failure there. And so other areas that require periodic maintenance and are identified in existing buildings when we do existing building tab is flow measuring station calibration. A lot of these flow measuring stations start to pick up lint or particulate, and they need to be cleaned so that they will can be calibrated. Strainers. This is another area where if they're not cleaned periodically, we're going to start building up a lot of resistance in the system, or maybe have coils that just are not receiving the design water flow due to some clogged strainers. That could also apply to our pumps as well, right? So sort of staying with the fan belts and looking at some specific examples here. And you can add to the Q&A on this topic here. These are just some examples to throw out. And, when we look at isolation room exhaust fans, for instance, we've got indicators in that isolation room, room pressure monitors, right? That might indicate, we're not maintaining proper pressure. That would sort of lead us to troubleshooting in this example, and maybe finding an issue with a fan belt. So in some areas we do have indicators. Another example would be a fume hood exhaust fan, and some fume hoods are equipped with low flow alarms that would indicate a problem, persistent problem that might lead us to that. The stairwell pressurization fans, we talked about, annual testing is sometimes required there. But if it's not being performed, there's a good chance that you've got, a lack of maintenance and checks on those fans, where, again, your belts could be degraded or cracked or broken even. And one thing to point out about our stairwell pressurization fans when it comes to belts is that they're required to have 1.5 times. Oops, I don't know how we went there. 1.5 times the number of belts for its given rated horsepower. So that minimizes the opportunity or the chances of not having any belt, to perform. But it just, I guess, highlights the criticality of belts when it comes to these fan systems. Then the general exhaust fan, we might find a nuisance odor not being controlled there, or maybe a building pressurization issue might lead us to a further investigation on that general exhaust fan. But these are just some areas. And again, if you have any other examples there, feel free to add those. Okay. There we go. All right. So when we think of our system performance and how does the HVAC system impact our indoor air quality? So balancing of systems restores our proper ventilation rates, thinking about our outside airflow that has to do with maintaining our comfort, but also compliance with codes. And so our ASHRAE standards will provide a ventilation rate based on occupancy. And so sometimes when we're working with existing buildings, the occupancy of today's building operation and usage is different than when the building was first designed. So that needs to be contemplated. It needs to be reviewed. And obviously we need to measure the current outside airflow rate and then perform balancing to restore the proper for today's usage in that building. And of course, fundamental to test and balance is our hot and cold spots. That the idea of balancing to balance in accordance with the connected load and distribution just comes along fundamentally with every project. And to underscore the significance of indoor air quality, we can look at an enclosed, contained environment. I had the opportunity to serve in the Navy and work on and get deployed on a nuclear submarine, and it's pretty fascinating the way that they maintain the indoor air quality. But back in the World War II era, when you had the diesel electric subs, they just cruised on the surface mostly, and whenever they went submerged, they had no means of taking care of CO2 buildup or the oxygen depletion. And so that was the limiting factor of the amount of time they could stay submerged. And so it was usually less than 24 hours. Whereas today in the modern, submarines, they're all nuclear. Your ventilation rate, first of all, is about 10 air changes per hour. Pretty high ventilation rate, and it's a pretty loud white noise that if for any reason those systems shut off, it will wake you from being asleep. I mean, it's pretty wild how that white noise exists. But it's a pretty neat process to get rid of CO2. They've got this amine-based scrubber that absorbs that CO2, and then when it's heated, that solution's heated, the CO2 gets released, and then the amine gets cooled and used again. So it can be reused over and over again for the duration of a sub being submerged, and then the oxygen is created by taking seawater and distilling that, basically boiling that off and collecting the pure water, taking that water then and splitting it into oxygen, hydrogen, get rid of the hydrogen because it's highly flammable and explosive, but and then maintaining that oxygen level, CO2 level, using atmospheric monitoring systems, and that can be, you could stay submerged for months. And the limiting factor in that case is food. So it's pretty interesting, but it just underscores, the significance of indoor air quality, and in our buildings, it's the HVAC system that is providing that, that lifeblood and that healthy building environment for the occupants. So clearly, an unbalanced system is going to force equipment to work harder to meet set points, and that's going to increase our energy use. And so our tab is going to ensure that our air and water flows match the actual load requirements, again, considering these loads may have changed from the original design. Some examples of that would be space layouts. So literally moving walls, or demoing walls or adding walls, changing space layouts. And the HVAC system needs to be reviewed. The HVAC distribution of airflow needs to be reviewed at that point, and changes need to be made accordingly. Occupancy levels we've touched on can change. Equipment loads increasing and decreasing, and that could be, it could be lighting, it could be, again, occupants, computers, any heat producing refrigerators, things like that. Anything that's going to provide a heat load. All of that needs to be taken into account, and these things do change over time in existing buildings. I didn't ask the question if we have any building operators in here, but I don't think we have any. I can go ahead and pick on them because they're not here. But they have a tendency to maybe just go into the BAS in the building automation system and maybe override an airflow set point to respond to a hot or a cold call. Or maybe they're going to close their outside air dampers because they're not maintaining conditions. But this is just a symptom that needs to be addressed, holistically, and not just go and make one change that's going to impact something else, within the building system. They may have a tendency to adjust manual volume dampers. We've seen marks on ducts that say summer setting and winter setting for a manual volume damper, and somebody had that as their way of maintaining, but that building operator might have moved on. And again, I think it's a symptom of a larger problem that probably needs to be addressed. You might have some other good examples that you can drop in the Q&A there that happen in existing buildings. So let's talk about the test and balance process. If you're a TAB professional, you know this process. This is how you approach all of your projects, by starting with the system inspection, the preliminary assessment, which is measurement and data collection. And we talked about some of those specific airflow and pressure temperature type measurements that we're getting to determine capacities. The system analysis is where we're looking at those control strategies that are currently in place, and then contemplating control strategies that we could perhaps add or implement, troubleshooting to determine if something's not working properly, and then we start making system adjustments to get airflows to design. I want to pause right there because you can't go to step 4 if you need new design calculations. The TAB professional is not expected to make those calculations. This is where we probably need to bring in a design. We need to engage a design engineer. We'll probably need to start building a team. We're basically starting to get into a recommissioning process here. So our ACG partner firms, EMA partner firms can come into play. So let me ask our polling question number 5 here before we finish these steps. How many attendees have partnered with an ACG firm, a commissioning firm? And if your AABC firm has an ACG certification or a sister company that performs commissioning, you can answer yes here as well. Okay, what do we have there, Will? So 73% have partnered with an ACG firm. And so good. A lot of the ACG firms are also design engineer firms. They have registered professional engineers on staff that can collaborate in this regard when we're trying to get to step 4 to make those adjustments and have the proper, newly calculated design flow rates for a current usage. And then question number 6, we could bring that one up now. How many attendees have partnered with an EMA energy management firm? And again, yes, if your firm has that certification or a sister company that performs that role. Okay, what do we have? So a lot fewer, and that sort of falls into line with the number of EMA firms out there versus like ACG firms, for instance. So, but they're a key role too, and they've got a nice perspective or a unique perspective on the energy management of these systems. And so when we're really trying to target that efficiency and optimization, an energy management professional has some tools that could come in and help us, document where we are and how to get to maybe an energy usage goal. And so in the end, we're going to make final reporting and recommendations. but in that final report, if it's just a bunch of data without a system understanding or a building understanding, it's not going to be as useful, right? And so that's why a lot of times we do need to bring in other professionals with the TAB professional to achieve a result and a final report that have meaningful recommendations. And as soon as my computer allows me to advance this slide, we will go to the next slide. Apologize for the delay. There we go. All right, so some of our common problems that are addressed in existing buildings, and feel free to add some of your own experiences. Airflow imbalances. If we're out of balance for ventilated spaces, might have duct leakage. We talked about restrictions. Here's a picture of a restriction in a flex duct. We just have too much flex duct, or maybe the hard duct is extended too far, and we're trying to bring that flex back in front of that slot diffuser to connect to it. And now we just got this, Z-shape restriction there. That system has to overcome that restriction to get the airflow out of the grill. Temperature inconsistencies. Now it's going to give us another advancement. Here we go. The crawl spaces, hot, cold spots, we kind of touched on, and then the inefficient equipment operation. And anytime we think about underperforming or overperforming pumps or fans, we think about the energy efficiency losses there associated with that. And we know that as we increase airflow for a pump, for a fan, or water flow for a pump, if we increase airflow 10%, the power consumption goes up on the cube, 1.1 cubed. So it's a very easy way to start finding some low-hanging fruit when we identify, overperforming equipment. Okay. Some of the standards and regulations that come into play and are referenced in testing and balancing is ASHRAE standards. So the design under ASHRAE standard 90.1 for energy efficiency. And again, these go into consideration for new design, but sometimes existing buildings maybe were designed prior to the advancements in these energy standards and energy codes that exist today. And so that's where we look at our local regional building codes and see how they may be retro commissioned in an existing building. The USP 797 and 800 applies to pharmacies. And so pharmacies are now getting upgraded to comply with new standards, like the new standard USP 800 for air changes and pressurization. So TAB is a very critical element there. This ALAC acronym deals with animal labs and vivariums. This is a voluntary accreditation, but a lot of the animal labs use this for their own compliance. Apologize. LEED and green building certifications actually do call for ongoing TAB. Unfortunately, they're not really enforced that much, but it is a big part of those programs. And then we have our AABC national standards. Other ASHRAE standards we touched on, ASHRAE 170, that comes into play for these critical care environments and so forth. So a lot of standards and codes that come into play there. So here's something that we can use as a guide to work with facility managers to develop a periodic test and balance plan for a given building. And so we can take these steps and sit down and apply it to a particular environment, particular usage space, whether it's K-12 or universities, or there's a lab versus classroom. There's so many unique applications, Class A office space. But we're going to have a plan to assess the systems, set up a schedule, and then identify our key performance metrics. Once we get a baseline, then this plan can be implemented and monitored over time. And it allows us to see how things are trending, if something's changed, from the previous test, and then prioritizing areas for immediate attention with an action plan for any type of underperforming, overperforming, out of tolerance or aging equipment that needs to be replaced, and so forth like that. And so how do we enhance our indoor environmental quality through test and balance? We're going to reduce our pollutants like CO2 and VOCs with proper ventilation and proper filtration, which is going to provide us better airflow and ventilation and give us a healthier building. And, it's going to be more comfortable and productive for our occupants. And so all of this is very important. We went through a big shift in the way buildings were set up when we went through COVID. ASHRAE formed an epidemic task force with a lot of guidelines that came into play, and a lot of buildings were building HVAC systems were changed, modified. And so we've got existing buildings today that need to be brought back out of that, or maybe some hybrid of the previous settings and what we actually need today. Again, occupancy has changed in buildings a lot, and that continues to change. So a periodic review of the test and balance is very important. So in conclusion, some of our takeaways here today in this session is just periodic test and balance is essential for maintaining our system efficiency, and regular testing extends system lifespan. It reduces costs because we're operating the equipment at the most efficient operating point. It's going to improve our energy usage, our indoor air quality and comfort. And I apologize. And developing this plan is going to be crucial for ongoing building performance. And with that, we'll take any other Q&A to close out the session.
All right, thanks so much for that, Troy. We've got a question in the Q&A, and just a reminder to everybody, you can go ahead and add your questions in the Q&A button at the bottom of your screen, and we'll ask Troy. That was a great presentation. This question says, I currently work in the large-scale data center industry as a mechanical commissioning engineer. A lot of times the client and the general contractor look at TAB as a box on their list that needs to be checked off with minimal reference to the TAB report. What are some of your suggestions in building value of the TAB contractor in industries?
That's great. And so, yes, coming from the commissioning side, I think one of the things we can do on the commissioning side, which I'm part of that industry as well, is utilizing the contract requirements. If we dive into specifications a little bit and treat that TAB report as a submittal that needs to be reviewed for compliance with the specifications, we can add or increase the significance of that TAB information. A lot of times in the TAB report, there are underperforming systems at the time of construction and that need to be addressed, and sometimes those are overlooked. So I think adding your input as a commissioning professional back to the design team and project team helps validate the significance of that TAB data.
All right, thank you. How often, talking about recommissioning, rebalancing, how often should a building be rebalanced?
So it's going to vary. We just talked about a few different sectors out there, like healthcare, hospitals. We really need to be in there annually to maintain their accreditation and credentials, to document that all of their critical care spaces are meeting the ASHRAE 170 standard in this case. Laboratories where, the higher the risk, the more frequent we need to get in there and check the airflows and pressurizations and all of the TAB information. So some of your labs might be quarterly or biannually, every 6 months. Schools, universities, you might think of a 3 to 5 year frequency. Again, looking for that change of either load or usage or occupancy, things like that. Those are some examples, but basically the higher the risk, the more frequent you want to be in there checking on those critical airflows and pressurizations and performance of the HVAC systems.
And during that rebalancing, do you need to perform tab services for every piece of equipment?
I guess the correct answer is no. It would depend on the scope of the periodic T&B. Where did the request originate, and what are we focused on? So we may just focus on some equipment. However, since everything does, the performance of one piece of equipment affects the performance of another piece of equipment, right? So we might find ourselves going down a trail that does end up being a full-blown, you know, complete HVAC system test and balance. But there could be cases of a focus on a particular system that doesn't include other systems in the same building. Yeah.
All right, we've got a few more minutes if anybody else has questions. Next, this says, is it recommended to confirm building pressure during a tab service for an existing building?
That answer is yes, and it's always it's critical that we're paying attention to what's happening with building pressure in various modes of operation of HVAC systems, and that controlling that building pressure is going to allow us to control particulate that might be brought in through infiltration, and moisture that's going to be brought in through infiltration. All of that needs to be brought through the HVAC system so that we can filter the air and condition that air before it's introduced inside the building. And these are the types of things that lead to, mold and serious IAQ issues, as well as comfort issues, just not maintaining the indoor environment, environmental temperature and humidity, right? And so I think many of us have experienced walking into a restaurant in the winter time, and the host or hostess is standing right there near the door of the vestibule, and they've got a coat on, because all of this cold air is rushing in the front door to replace all of the air that's being exhausted through the kitchen hoods. And for whatever reason, it's not being made up. Maybe the makeup air fan was turned off, or maybe it has a broken belt that we touched on, or maybe they were not bringing in enough outside air through the other HVAC units. But that building pressure is critical in all buildings. And so, yeah, I think, yes, you would want to pay attention to that building pressure when you arrive, as part of your baseline assessment, and when you leave, so to speak, after performing those 5 steps of balancing. That should be noted in your final report, that building pressure. Yes.
All right, and with a couple minutes left, are there any projects that you may have encountered recently that relate to this topic, and any insights from those that you could share with the group?
Yes. I think besides the regularly scheduled frequencies that we've talked about, like annual testing of hospitals and things like that, or annual testing of stairwells, we're working on a project now that involves basically, it's a pharmaceutical setting, but it's not the highest level of pharmaceutical requirements. These are like vitamin supplements, but that this company is producing, but they still are trying to maintain indoor environmental conditions of temperature and humidity as they're handling this product, and then pressurization and so forth. And so, in an effort to maintain the indoor environmental temperature and humidity, a decision was made to close off outside air to units that served all of these production areas where they had this product, this powdery product that would become gummy if you had too much, humidity in that space. So, as a result of closing off, a large quantity of outside air, we're talking, maybe 16 air handlers that, we're going to handle 300 or 400 CFM of outside air each. So after that was done, building pressure in the surrounding spaces outside of production, the whole building went negative. So all of that moisture and humidity began to migrate into production because there was not a big segregation between production and the superstructure, we'll call it, or warehouse around it. And so a lot of effort went into it with test and balance, commissioning, mechanical contractor, design engineer, general contractor, everyone, controls contractor working together, and manufacturers reps to come together and take a stepwise approach to getting the building pressure under control, but also maintaining the proper indoor conditions for the production areas. So pretty interesting. But yeah, it goes to show how the original design intent we can't always just go back to original design. Sometimes there's a reason that things have been changed, and when they have an adverse effect elsewhere, there needs to be a solution that doesn't compromise the overall intended purpose of the space. Yeah, so it's pretty interesting stuff.
All right, well, thank you so much, Troy, for all your insights today. This has been a great webinar. And thank you to Evergreen Telemetry for sponsoring this session. And finally, thank you to everyone who joined us today. We hope you found this session insightful and full of takeaways that you can take into your own work. We cannot wait coming up. We cannot wait to celebrate 60 years of AABC with you at the 2025 AABC annual meeting in beautiful Amelia Island, Florida. So we hope that you can join us October 22nd to 24th for some ocean views, networking with fellow AABC members, and expert insights from professional presenters in test and balance. So mark your calendar for that, and you can learn more at aabc.com. We also hope you can join us September 11th for the CX Energy Virtual Technology Showcase, an opportunity to hear from a variety of sponsors about the latest trends and technologies in tab, commissioning, and energy management. You can learn more about that one at cxenergy.com. Thank you so much, Troy, again, and thank you for everyone joining us today.
Thank you.